Yeah, we on the space station, especially as a scientist, is the diversity of all the different scientific experiments. So for me, my background is in physiology. I loved being a part of these physiology and medical experiments on the ISS, so trying to understand how spaceflight and the microgravity environment affect the human body. We have combustion experiments because even flames burn differently in space. We have protein crystal growth. We had the biofabrication facility up there, which is really a phenomenal piece of hardware. It's really in the test concept phase right now, but it is basically a 3D printer that is using human tissue, and the eventual goal is that it would actually be able to print a human organ for a transplant procedure back on Earth. And the idea there is when we try to make artificial organs here on Earth, you need to have some kind of support structure in there in order for the tissues to grow thick enough to form an organ. So the hypothesis is that without gravity, in microgravity on the space station, you would be able to grow these layers of cells and tissues thick enough so that you wouldn't have that support structure there, and that support structure has to be removed and can damage the cells. So you might actually be able to grow an entire organ. We had several experiments looking at bone cells and also looking at muscle cells, looking at cardiac tissue. We know that astronauts experience a lot of changes to their cardiovascular system due to microgravity in that environment. And so trying to understand the expression on the gene expression level, why that is happening, and on the tissue level as well. We've done a lot of experiments in the past measuring some of those cardiovascular aspects, but not really at the tissue level. So we had these little tissue engineered muscles that were spontaneously contracting, just like our muscles, and we were fixing those at different time points so that we can analyze them and see how microgravity is changing those muscle cells. We were growing Mizuna lettuce, so that's really important for the future exploration, having a sustainable food source. So we had two different types. We had Mizuna lettuce, which we actually got to harvest and eat. You had some of that?
We had some, but we were in the early part of the experiment where we each got like a kind of a leaf. So it looked like your harvest got a little bit better with progress.
we did actually get to have a whole salad, and that was a great treat for us to have some fresh vegetables up there. And just before leaving, actually, I started an experiment that was growing romaine lettuce. So Chris Cassidy's up there now. He'll be monitoring the growth of those ones.
Well, good. They'll get lots of lettuce back. And so for those of you who don't know, Jessica and I were classmates when we first got to NASA, and I saw a question pop up about what our backgrounds were. And, Jessica's a scientist, and I was a aeronautical engineer, test pilot. And what's really fun is that we've been friends since we got here, and we both came in with such different skill sets. And some of my early training, I remember when I did all the same type of science, a little bit different experiments, but much of the same genre of science when I was up on space station. And so I had to get taught that, when I was at NASA. I didn't have a background in that. And I went through some science courses with Jessica here next to me. And, I highly recommend the first time you learn science to have a PhD scientist next to you answering all your questions. And what was really neat about it to me is that I realized how, it's going to kind of sound goofy, but how rigid the science actually is. I guess I had this picture in my mind, like, you make a hypothesis and then you go, there's a bunch of gray area and you go figure it out. But something that I learned from Jessica, what I learned now on the International Space Station is how scientists put together very rigid criteria for finding answers to big problems. And that was such a cool thing to be part of on the facility. But the ISS is a national laboratory, actually.
That's right.
And so there's a segment of the International Space Station is designated a national laboratory. And what that means is that our national laboratories across the country are funded by the government. The research is conducted for the good of the people. It's these big multidisciplinary problems. They're not they're not for private companies, but they're for the good of all of us. And so it's really exciting to be part of some of that research on the space station.
Right, and it's something that, we're using these results that really belong to everyone. It's not really to just one entity. So it's pretty exciting that we have the International Space Station designated as a national lab. I think that's an important aspect of what we do. Yeah. And, on the flip side of what you were saying in terms of the science, for my background being a scientist, for us going through the training in the beginning, I had to learn how to become a pilot. So I had people like Anne who were professional pilots before becoming astronauts to help us through that whole process. And I think to me, that's one of the coolest things about our job is that we do get to do so many different things. We're not just sitting in an office doing the same thing every day. One day I'm learning to become a pilot and then later flying airplanes, and then also still able to do some science, conducting experiments on the space station, going for spacewalks like Anne was talking about. And that, I think, is really one of the highlights of my mission, was doing those spacewalks, just like you said. I mean, that feeling going out the hatch and knowing that you're part of this incredible ground team that has designed this suit and kept this suit working and functional to support you, and designed this entire spacewalk so that we can do something big, like replace a whole battery channel, like you were saying. It is just such a phenomenal feeling to be part of a global team when we're up there.
Yeah, and today we took a scientist and a pilot, and we tried to figure out how to set up a camera and some lighting. So we're sorry if this looks a little bit JV. This is not either of our backgrounds or forte. There's a reason why there's professionals that do this. So for all the newscasters that are broadcasting from your living rooms, we have a totally new appreciation for setting up all your own video. But hey, we'd love to hear what questions you guys have. Jessica's fresh back from space, and I'm sure that there are some people wondering some things. I see a lot of people making comments, but what kind of questions can we answer for you?
All right, well, keep your eyes peeled on there, and let's see what else we have. We can talk a little bit about living in isolation. I mean, we've been sharing some of these on social media, and it's something that, of course, as astronauts, we are trained to do. And we receive a lot of training and focus before we go up about living in isolation, living in a